Hello everyone. Welcome to part 15 module 1 computer networks. So far we saw some introduction to computer network and we gone through what called the major functionalities of computer network, so as a main topic. And of course the categories of computer network, different things we come across. Now this is the point at which we can move on to the concept of layering. Okay, so what we seen so far are some design issues of the for the layers, right? So why layering, that we will see. Layer in the sense the overall software that supports this computer networking, you are going to implement as a layered architecture, so different layers and different set of functionality, and many functionalities we come across, and that is just listed here: error control, the error detection and correction, routing, internetworking, addressing or naming, the scalability concern, statistical multiplexing, flow control, congestion control, media access control, real-time service like quality of service, security, confidentiality, authentication, integrity, and not only that, the so-called compression, decompression, checkpointing, like that many things we discussed. So the idea is this list is not ending at this point, and it will keep growing. And with our time and our curriculum course, everything, we have some limitation for covering. So in literature, if you keep on counting them, so there are found to be around approximately 70 such functionalities or design issues the network designer should taken care. And what people started doing is this 70 around things we have to implement and we have to code them. Of course we can eliminate the optional functionality for the time being, and depending on the need we can add them, but still the mandatory at least we have to code, right? So when you are trying to code it, so what people thought is, instead of coding it as a single software code, a kind of programming methodology, so we call it as a monolithic programming, right? Maybe in our original, most of the initial versions of the operating systems were developed in as monolithic programming. So okay, we don't want this kind of an approach. Instead what we need is a layered architecture where the 70 plus or around that many functionality we divided into 7 layers. Okay, so some 7 layers in the sense this is so as per a reference model, there are 7 layers. This is something like a guidance, but again it's up to the designer whether he want the 7 layer or something less than that or more than that. It is not a fixed number, first of all. And what we have and what we are studying actually is own model. We call it as the ISO OSI reference model, which is a 7 layer reference model. So you have to remember that term. Reference in the sense this you can keep as a reference, okay, and it is not a practical one. And we have the so-called 4 layer model, 4 layer the TCP IP model, okay. So and in the Tannenbaum textbook it is found to be 4 layer, but if we are looking at Stalin's textbook, they are explaining the same TCP IP model as a 5 layer model. So it is all about the designer to come up with the correct one. So this number you don't have to worry, but anyway for ISO OSI reference model, this 7 layer that you can remember. So initially we will go through all these 7 layer, and then we will go to the more practical one with a reduced number of layers. So the differences, everything we will see at that point, okay. Now you will be thinking like, what about the 7 layer? If it is 70 around functionality, we can equally divide them into 7 parts, so that every layer is getting around some 10 functionality. But sorry, it is not like that. We are grouping the functionality depending on the means whether it is to be implemented at a very first phase, whether it is something lower layer to be implemented, or it is some higher layer. Okay, so depending on the level of abstraction we need, and something we can group together, okay. So those things we are grouping together, and accordingly we done that classification. That also I will try to give you a view like how people started thinking to group in such a way that this many functions are going into this and this, like that, okay. So we will see, and this everything is cleverly defined and experimented and finalized, okay. So we can just learn it like, okay, this is a particular layer and these are all the functionality that is given to it, and it is not a kind of equal division, nothing, okay. So So depending on the means their usage and which are all functions, when you group together you will get the optimal performance. So in that way that grouping is done. Okay, so anyway, we are going to divide the overall functionality into different layers. So before moving on to the actual ISO as a reference model or the TCP/IP model, and the name of the layers, their functionality, etc., we will initially see an overview of the so-called layering concept. Okay, so what you can see, the very first question that you may be asked by someone for interview and all could be, why layering? Okay, so that is the very first question. So we can answer with in a number of ways. Something I listed here, something which is familiar for you, try to list it. So this divide and conquer approach of design we can go for if there is layering. Okay, so I hope all of you are aware about this paradigm. Whenever you want to solve a very large problem, what you can do is divide that into smaller sub problems and conquer the sub problem independently and combine the solution back to get solution to the original problem. So this is something we are doing in our day-to-day practice everywhere, right? So this is a well-known algorithm when it comes to algorithm design. So here also what we are doing, our 70 plus functionality, we are dividing into we are grouping into smaller sub problems or sub functionality which can be implemented together, and then we are conquering in the sense we are implementing, and finally all together it form the original solution to the problem. And in object oriented design, what is abstraction, what is encapsulation, all those things you can see here also, in the sense whenever a layer is implemented, it is actually trying to provide an abstract view to the layers which is in communication with it. And normally lower layers try to give services to higher layer, in the sense higher layer can ask some of the service from the lower layer, and by that time it is the layer interface is there. So okay, so see, this is a particular layer I, and below to this layer we have layer I minus 1, say. So this numbering you can do in any way, or I and I plus 1. So this is the lower layer, so I am counting in this direction. So this layer is implemented many things. Okay, so and when this layer I plus 1 is looking at layer I, it is getting an abstract view only, in the sense the details are hidden from I plus 1 the layer. I'm just talking about layer I. It is providing an abstract view of the functionalities of this particular layer to I plus 1, in the sense the details of the implementation is hidden from I plus 1, and when I plus 1 is looking, we have the so-called layer interface. Okay, so in between we have the interface, the interface concept in Java programming, right? So that's same concept, and in that interface you can see whenever this layer I plus 1 is looking at the interface between I and I plus 1, interface between I and I plus 1, we may be noting down like this. At that interface, all the services which are being provided by layer I will be listed as the service name. It will be getting with the return type, what are the arguments to be passed. There is a prototype kind of thing is available, but you don't know how this service is actually implemented. That is up to this layer. So now this layer can be independently implemented and developed, and provided it keeps the services as per the interface. So this interface is something standardized one, and the implementation is something that will vary from one network design to another network design. So that kind of a flexibility also you are getting. Okay, now the third one, of course the encapsulation, wrapping up of the data and functions together, in the sense here layer I is focused what are all the things needed by layer I, and the functionality that will be bundled together, and it is not having any dependency with other layers. Okay. And of course when the code is developed as a layered architecture, it will lead to easy debugging and testing. Okay, like that you can put any number of advantages that we are seeing in a normal layered software design. So more about it, what is being explained in your Tannenbaum textbook. So to reduce the design complexity, most networks are organized as a stack of layers. So the layer 1, 2, 3, like that, you can see a layer stack, or each layer is having set of protocols associated with it. Together it will form the protocol stack, and each one built upon the one below it. The number of layers, the name of each layer, the content of each layer, or the functionality of each layer, and the function, that is also listed. The function of each layer differ from one network to another, of course. So layering, in the sense that implementation will vary, but they try to provide a common interface. So the purpose of each layer is to offer certain services to the layers higher to it. That, like, ith layer will be offering something to I plus 1th layer, while shielding those layers from the details of how the offered services are actually implemented. So whenever a higher layer is looking, it don't know how the services being offered by the lower layer is actually implemented. Simply it will provide an abstract view. So in a sense, each layer is a kind of virtual machine. In virtual machine also you don't know how the things are being implemented, but from the user point of view, he's getting the feel like he's using a actual physical one. So offering certain services to the layer above it. So this concept is variously known as information hiding, or abstract data types, or data encapsulation, and object oriented programming. So in all this context, you are familiar with such terminology, and the same thing you can apply here also. The fundamental idea is like this: a particular piece of software or hardware provides a service to its users, but keeps details of its internal state and algorithm hidden from them. So how things are done, that is hidden, but it will be providing that service. Accordingly, we have the so-called protocol hierarchy. Each layer we will associate set of protocols, and together it will form a protocol stack or protocol hierarchy. So when layer nth layer on one machine, so this layer n you have to highlight. So if layer n of one machine carries on a conversation with layer n on another machine, the rules and the conventions used in this conversation are collectively known as layer n protocol. So from the sender side, we have say layer 1, layer 2, layer 3, say 3 layer or 4 layer protocol, and at the receiver side also we have the same layers, right? Layer 1 and layer 1, say layer 2, layer 3, so everything work intact, right? Layer 4, and finally this layer 1 is trying to communicate with this layer 1. This is a sender and this is a receiver. Layer 2 of sender communicating with layer 2 of receiver. So in that case, you can see that layer 1 of sender is communicating with layer 1 of receiver using layer 1 protocol. Okay, so this is where the protocol is working. So that facilitates the communication between the corresponding layers at the sender and the receiver side. So that is what is listed here. Just read it again. The layer n on one machine carries on a conversation with the, say, layer n, 1 or 2, whatever it is, on another machine. The rules and the conventions for this communication or used in this conversation are collectively known as layer n protocol. Now if you see, basically a protocol is an agreement between communicating parties on how communication is to proceed. So this definition we already come across. So violating the protocol will make the communication more difficult. So it is something everyone participating in the communication is supposed to follow the protocol. So the layers, protocols, and interface and overview. So this is what I was trying to illustrate in the previous slide. So we have host 1 is trying to communicate with host 2, maybe the sender and the receiver, and we in this example there is it's taken a 5-layer architecture as an example. Layer 1 to layer 5, the same layer 1 to layer 5 at host 2. Also see, layer 1 5 to layer 5, the communication is possible by means of a specific set of protocols. We call them as layer 5 protocols, and similarly layer 4 to layer 4 protocol, like that. And in between two layers we have the so-called interface by which a lower layer is providing service to the upper layer. So we call it as like the layer 3 bar 4 or layer 3 to layer 4 interface. Similarly layer 4 bar 5 interface. So in this way you can name it, and finally the actual communication is happening in the form of binary information through the physical medium only. So this is something like this is where the application, so if I am interpreting host 1 as a sender machine, You can see that at the center machine, the application or the program or the user on the background is generating some information which he want to communicate with the so-called receiver. For that also, it may be he is trying to compose a mail and he is sending to the receiver, or he is accessing something, he is giving a command, whatever it is. Okay, so let me call it as the application, and this application is with which the user is getting direct contact. So user using an application is generating something called a message. So message is the name, you can give that information which he is trying to communicate with the other one. I am calling it as message. It can be an email message, it can be a text, or it can be a image, whatever it is. And this message, it will go through different layers, layer 4, layer 3, layer 2, and finally to layer 1, and each layer will be doing something over this message. And as part of identification of this layer, because at the receiver side also this layer has to be treated in the, maybe this layer 4 may be compressing the data, okay, and at the receiver side at the same layer this decompression should happen. So I am just taking an example. If layer 4 is trying to encrypt the data, at the receiver side the same layer should decrypt it, and the layer 4 is trying to, or layer 3 is trying to, whoever it is, say compress the data, the same, I'm just listing only, but functionality, actual layer mapping, that will vary, that we will see soon. The same layer at the receiver side will be doing the opposite phenomena, like decompression of the message. So how this is happening? So whenever you are compressing something or encrypting something, the encryption information, like what is the key used, what is the encryption algorithm used, everything you have to embed as an additional information into the original message. Okay, so what you will do with the original message, you will append something called a header. Okay, mostly header. Sometimes you will be appending a header and a trailer also. So message, at the beginning of the message you will append header, and if you want you can put a trailer at the end. So this header and trailer together defines the additional information, and every layer will add its own header. Mostly sometimes some layer will add their own header and trailer, and at the receiver side when we are reaching the same layer, by looking at the header and trailer, the layer will be understanding about what the corresponding layer at the center side is trying to communicate with it. Okay, it may be the encryption happens, so receiver will understand by looking at the header of layer 4, say, and it will understand that this is this is an encryption algorithm used, this is a method used, and this is a key, and using that it will decrypt correctly. So without this header or trailer, this layer concept is not complete. Okay, so mostly header, and sometimes header and trailer also. So every layer will attach its own header to the original message, which we will see in the subsequent slides, and accordingly it is communicating. And sometimes the message being sent by layer 5 to layer 4, and at layer 4 it may not be able to handle the bigger message as a whole, it may divide that into smaller pieces. Okay, and that when it comes to layer 3 it may divide it further, or it may keep it as it is, anything can happen. Okay, so depending on the type of computer network and its requirement and the functionality it is providing, that division of the original message into packet size, everything will vary. Okay, so all those things you have to consider. And finally, when it comes to layer 1, mostly the information is just in the form of zeros and ones, and now these signals and bits will get encoded to some signal, some kind of Manchester differential Manchester encoded signal that will be passed through the physical medium, and at the receiver side that encoding again at layer 1, this decoding will happen. You will get the original message, and that will be grouped into the so-called the unit of information. It can be a packet or whatever it is, and again it will group together into so-called message, and finally it will be delivered to the application which is running at the receiver side. So this is the overview, and what is the protocol, what is interface, what is layering, the header, trailer, that kind of additional information each layer is attaching, everything you got an idea, right, at this point. Now maybe with this we will end up another some terminologies only. The peers and protocols, the entities comprising corresponding layer on different machines are called peers. Okay, so the sender or the receiver, what we seen previously, host 1, host 2, like that. So those things in general we call as a peer, and the peers are supposed to be divided into when they participate into communication, it is going through different layers. The peers may be a software, process, hardware, or even human beings, the who is trying to communicate. So in other words, it is the peers that communicate by using the protocol to talk to each other. So in reality, no data are directly transferred from layer n on machine to layer n on another machine. Instead, each layer passes data and the control information to the layer immediately below it. That is what we seen in the previous slide. Layer 5 is giving handovering things to layer 4, layer, and until it goes to the lowest layer, right? So in that way the information will flow, and below layer 1 is what we call the physical medium through which the actual communication occurs in the form of signals, digital signal mostly. So in the figure of the previous slide, the virtual communication is shown by dotted lines, and the physical communication is by solid lines. So if you want, you can see the slide. So that dotted lines are for virtual communication. Actually there is no direct connection between them. The actual physical communication is shown by the solid one. Okay, so that is through the physical medium only. Okay, now I think this we will cover in the next part of the video. So you got an idea about what is this so-called layering and protocols, the header information and trailer, and that I will discuss in the next video also, but anyway I explained at this point. Okay, thank you.